Hi everyone, and welcome to sudo rmrf Capstone project. In this video, we'll walk you through a deliberately vulnerable banking website we've created as part of a security demonstration project. The goal, to explore how real-world web attacks happen and show exactly how developers can prevent them. From SQL injection to cross-site scripting and even remote code execution, this project covers some of the most common and dangerous security flaws found in the modern web applications. This is a learning tool for developers, testers, and anyone interested in cybersecurity. Let's dive in and see how easily a small mistake in code can lead to a big security risk. Let's look at SQL injection, a critical vulnerability in the demo website. On this login screen, user input goes straight into a SQL query without validation. That means if someone types quote OR1 equals to 1 hash as the username, it changes the query logic. The quote OR1 equals to 1 hash always evaluates to true, so database grants access regardless of the password, effectively bypassing authentication. Here you can see the system logs in without valid credentials, and now you can see the user's personal information which should have been protected. Behind the scenes, the login system takes the username, password, and inserts them directly into the SQL query, as you can see right here. We fix this by using prepared statement safely separates user input and from SQL code, like this one. After the fix, this attack no longer works, and the login fails as expected. Now let's look at cross-site scripting, a vulnerability that attackers run malicious script in the user's browser. In our demo login form, the input fields don't sanitize user input. That means if someone types something like this into the username field, the script runs immediately after submission, triggering a pop-up in the browser. This happens because the app directly inserts user input into the page using HTML without escaping special characters. It looks something like this. To fix it, we create a function called escape HTML that safely converts special characters into plain text. Now when we use the function before inserting the input into the page, the browser treats the script tag as text, not code. As you can see here, after the fix, no script runs and the input is safely displayed. And now let's hand it over to Martino to explain more about other types of web vulnerabilities.
Thank you, Marvin. Now let's begin with CSRF. Cross-site request forgery, or CSRF, is a type of attack which the attacker tricks the user into executing unwanted requests. The attacker usually does this by crafting a malicious link or embedding a hidden form on a fake website, and then getting the victim to visit the page. Let me give you a simple example. Let's say I'm currently logged in as an administrator on our banking site, like you see, like this. So from here, now imagine that I click on a link in a spam email, thinking it's just a funny YouTube video. So when I click the link like this, so at a first glance, this website just looks harmless. It just redirects us to a YouTube video. But in the background, the attacker's page secretly sends a post request using my administrator session. That request creates a hidden bank account on the server controlled by the attacker. You can see when I refresh this page, the account for the evil hacker has been created. Now, later on, the attacker sends the same link to regular customers. If a customer is logged in and clicks the link, as the administrator did, they will also see the same countdown and the YouTube redirections. So let me log in as a customer. The customer has $8,000 as a available balance in his checking account. Now, if the customer click the same link, you can see the same uh, congratulations and redirections. And When you refresh the customers page, you can see that the available balance has been decreased to 7,000. And when you go over and look at the administrator portal, you can see that the evil hacker now has a $1,000 in his checking balance, which has been transferred from the victim. Now let's talk about command injection. Command injection is an attack which the attacker inserts system commands in the fields to execute the code. This is similar to SQL injection, but this attack focuses on the server more than the database. For example, the attacker can insert a system command in the username field when they log in to get the access on the server. Let me show how it works. In the username field, when you try a regular username like ABC and ABC, this one doesn't work. It just shows a general error message. But when your username includes some special characters like %, double N, or double bar signs, some special error messages appear. So when you have double bar signs here in the username field, and let me try just like this. Yeah. Now you can see some special error message which says IP address must be specified. This is the error message from the Windows command line, which means that you are executing the code in the Windows server. Now let me execute some system command here after this double bar signs, like who am I? So who am I is a command to print out the server's name. So when I try this command in this username field, you can see this another error message here, and below that you can see Martino \mkimh. So this is the server's machine name. Not only the who am I command, but also the other system commands will work by this command injection attack.
Hi, my name is Manuelito and I will demonstrate SQL injection combined with remote command execution. You've previously seen a demonstration of SQL injection. Now I'll introduce you to remote command execution, or RCE. It is a type of vulnerability that allows an attacker to run system-level commands on the server from a remote location. When combined with SQL injection, this too can be extremely dangerous. It allows an attacker to inject malicious code into the database and use that code to create a backdoor on the server. Let me show you how it works. First, I'm going to run this SQL injection into the login. Now, when you look at the right side in the victim's web server, this command created a shell.php file. This file will act as a backdoor, allowing me to execute terminal commands using my browser only. Now I'm going to try to run the whoami command. Now this confirms that I can now execute commands on the server. At this point, I will begin executing a payload that will deface the website. First, I'm going to send this payload to the victim's web server. Now I'm going to run this code. This will decode that payload into the victim's web server. And finally, I'm going to run one more code, and this will connect that payload into the index.html of the web server. Now, as soon as a user visits the website, the malicious script runs and the website is visually defaced, showing that this has been compromised. Now, this shows how dangerous SQL injection combined with remote command execution is. I am not just limited to destroying the database, but I can also take control of the entire web server. To prevent this attack, user input must be properly sanitized in all SQL queries to block injection. File systems should be restricted, and a web application must not allow SQL to write files to disk. And additionally, disable dangerous PHP functions like system function and apply least privilege principles to limit what the web server can execute.
Thank you for joining us on this walkthrough of our vulnerable banking website. We hope this project showed you how small coding mistakes can open the door to serious security threats, and how simple fixes can protect against them. Whether you're a developer, tester, or just curious about cybersecurity, remember that staying informed and vigilant is key to building a safer application. If you want to learn more or have any questions, feel free to reach out. Thanks for watching, and stay safe out there.